Morning, guys. Today we're going to work on our Math 1 Inequalities Review worksheet. We're going to do about a page today, and then we'll do about 2 tomorrow and finish it up on Monday, just because this first part is heavy on the graphs. So, looking at this, it's talking about the solid versus dashed lines. A solid line connects the points when, if we remember correctly, that is when we have a greater than or equal to symbol gives us the solid lines. Okay, so these are the signs that you use for solid lines. Dashed lines are when they're greater than or less than. So that is all you need to write for those, is those four symbols there. Okay. Shading, if the inequality is in a slope-intercept form, blank or blank shade above the line. Honestly, I don't remember which one that would be, so what we're going to do is we're going to skip that for now, because if the point worked, I want to say is we shade above the line. If the point did not work, we shade on the opposite side of the point. So I don't know what they're asking there, so just skip this for now. I will come back and answer that at a later point. Problem 1. Graph the linear inequalities, then name a possible solution. So if we look at this, we got to look at this first part here. Okay, so this is our function right here. This part here, as we've talked in past, is our y-intercept. And this part here, in the pink, is our slope. So we worked on this in the past, the last couple chapters now. Y-intercept is the first point we have to graph. Because it is a -1, it's -1 there. We need to know that it goes on our y-intercept, which there's our y. So our first point would be right here at -1. The next part, our slope, because there is no sign right here. There is nothing right there that says it's minus or whatnot. It says it's only, means it's a plus, positive. So because there's no negative sign means it's positive, means that the slope is going to go up. And to count this out, we look at it as 3 over 4. So we have to go rise over run. So we go up 3, rising over and that stuff. 1, 2, 3, and our run is 4. So we go over to our right 4 because we know this is positive, so it's going up. 1, 2, 3, 4. So there's our points right there. Now to make this a little nicer and easier for you to connect lines, you can do the opposite to find out going down to the bottom, is that you have to go down 3, 1, 2, 3, and over to the left 4, 1, 2, 3, 4. So that your graph would be a solid going across there. Now, make sure, I'm going to put this in yellow, since you see that line, you know that this is going to be a dashed line. Okay, so now you just make a dashed line going across here. Is all that you need to do for this problem there. Okay. Now, it's asking for a possible solution. So it means we have to find two numbers that will work. So we pick two numbers above the line. Okay, so let's pick one, an x and y number above this line. Let's just test that. Let's go 1, 1. So we're going to pick this spot right here because it's above the line. So let's see if that works. Okay, and it's easy numbers. So let's test it out. Y is 1, we said, is greater than 3/4, or is less than 3/4 times 1 minus 1. 3/4 times 1 just gives us 1. Or I'm sorry, gives us 3/4. Now we times, or minus 3, or 3/4 minus 1 means we're going to be at -0.25. So that does not work. So we know that any number above this line will not work. So we have to pick a number below. So let's try another number. Okay. So we're going to pick, let's go with x is 2, y is -1. Okay. Y is -1 is greater than x is 2 minus 1. Okay, so once again, use your phone, handy dandy calculator app, whichever one you want to do. Put in alpha y equals, do 3 divided by 4 times 2 gives you 3 over 2 minus 1, ends up giving us 0.5. So negative 1 is less than 0.5, which is true that it works because 0.5 is a bigger number than negative 1. So our points of x is 2 and y is negative 1 is a possible solution to this problem. Okay, so this one here works. So if I had asked you to shade the side that works, you would then have to end up shading this side down here because it worked. Okay, so that's all you would have to do. You plug in two numbers in, an x and a y number on the same side or one side of the graph, and see if it works. Now, if we look at this problem here, we're going to look at this part here, and this part here, and lastly, that part there. Okay. Now, because we see that it's a plus 5, we know we're going to be up here in the positive. So we can make a point there automatically and be set. Now, when we're looking at the negative 1/2, because it's negative, it means we are going down. It means it's falling down the hill. So negative, ball rolls down the hill. Positive, ball's being pushed up the hill. Because it's negative 1/2, we have to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. You can check the other way too to make sure you can come across to the left side. You go up 1 to the left 2 then. Now, because you have this symbol there, that's a solid line. So you just draw and hold a line across, let go, and it gives you the solid line. Now we have to test a possible solution. So let's pick a number. Let's go below this time. So let's go with number 1, 1. Okay, make it nice and easy on us. 1 is greater than or equal to negative 1/2 times 1 plus 5. Negative 1/2 times 1 just gives us negative 1/2. Plus 5 gives us 4.5 is less than or equal to 1. That does not work. So we know that this problem here in the yellow does not work. So now let's pick a number above. Let's go with an easy one. We're going to go x is 1 and y is 5. Okay, so this point right up here that I'm going to put in red is the point we're going to pick. So let's try that one out now. Okay, so we're going to put y is 5 is greater than or equal to negative 1/2 times 1 plus 5. Once again, negative 1/2 times 1 gives us just negative 1/2 plus 5 gives us 4.5 is less than or equal to 5. That's true. So for that problem, I would have you shade this top part up here that works. Just like that. That means our problem possible solution is 1, 5. Because we have the 1 is our x and 5 is our y. Okay, that's what that problem would look like. Now, this one's a little more tricky because it is not the same as B or A, how it looks. It does not have y is greater than or equal to or y is less than or equal to or anything like that. This has 7x plus 3y is greater than negative 15. We have to do some math here. We have to move negative 7x on each side, which now gives us, I'm going to write up top here, 3y is greater than negative 7x minus 15. We have to divide on each one of these by 3 because we want to get y by itself. So we're going to divide 3 on each side. And because it's divided by a positive number, our symbol here does not change. If this was a negative 3 and we divide, then our symbol changes and flips the other side. So this leaves us as y is greater than negative 7 over 3x minus, and we should know that 3 goes into 15 5 times, so it leaves us as minus 5. So now we took this whole problem right here and made it into this nice and easier problem to graph. Now we have to look at these parts again. This part there, that part there, and lastly this part there. So we see that it starts at negative 5. So we can go automatically down here and make our first point there. Okay. Now, because we see this as negative 7 over 3, it makes it a little trickier. Okay. Because it's not a whole number and it's not just going up 1 over 2. We are going down 7 to the right 3. Well, if we look at this, we can't go anywhere farther to the right down. Okay, because we're negative 5, negative 6, and the graph ends. So, to solve this, we have to go the opposite direction. So we have to go up 7. So we're going to go count up 7. 1, 2, 3, 4, 5, 6, 7. And to the left 3. 1, 2, 3. Up 7. 1, 2, 3, 4. Up. Can't go up any higher. So those are our 2 points that we can do right now. Now, for this, what you end up doing, because it's a less than or greater than sign, we have to do a dashed line. So just do your best dashed line that you can. Doesn't have to be exactly perfect. There's your dashed line. Okay. Now you've just graphed 3 problems with the function like that. Now the next part is we have to find a possible solution. So let's pick a number, easy number again. We're going to go with 1, 1. I pick 1, 1 just to make it easy, or 0, 0 depending on where it's at. Try and make it as easy as you can on yourself. Okay? So if we look at this, 1, 1. Y is going to be 1. Let me make it better, greater than. Y is greater than negative 7 over 3. Hold on. Right where I have some more room. We're going to do it right here. So 1 is greater than negative 7 divided by 3 times 1 minus 5. Negative 7 over 3 times 1 just gives us negative 7 over 3 minus 5. Ends up giving us, just to make it simpler in our head, ends up being like I said, I would expect you guys to use a calculator here. Make things easy on you. Ends up giving us, so that 7 over 3 would be 2, negative 2, 1/3, minus 5. Ends up giving us negative 7 and 1/3 is less than 1. And that is a true statement, because any positive number is greater than a negative number. So our problem here, possible solutions could be 1, 1 works. So then you would just take and shade this side of the graph, because that worked. Now if I picked a problem like we did in the first one that did not work, or actually the last 2 that did not work, you would not shade that side. You would only shade the side that, come on calendar. Sorry guys, I'm trying to get my calendar out of here. You would only shade the side that the problem works. So if the numbers work and make it a true statement, that's the side you would shade. Okay. Now, problem part 2, graph the solution to this system of inequalities and name a possible solution. So I'm just going to have you guys graph these. Okay, I don't need you guys to give me the possible solutions right now. Let's just graph these. So once again, we have to look at this and that, this and that, and lastly that and that. Okay. Now, the first part, we see that as negative 3, so we have to make a dot at negative 3. We have to look and see what it's moving by. It's going negative 2 divided by 3. Okay? So we go down 2 to the right 3. Can't go any farther down to the right, so now we got to go up 2 to the left 3. Up 2 to the left 3. And now, we're not done yet. Now we look and see that this is a greater than or less than sign. So now we know that's going to be a dashed line. So we just have to make, like I said, it doesn't have to be perfect. Just make the best dashed line that you can going through these points. So you know that's part of that problem there. Now, this part here is pretty much done. Now we have to graph the next one. So we look at the next one we have as plus 1. So we know the plus 1 is going to be right there. Okay? Now, this is where it gets kind of interesting. It says 2x. So while it's not a fraction, it's essentially 2 over 1. So that means we're going to go up 2 to the right 1. Up 2 to the right 1. Find on the other side, we go down 2 to the left 1. Down 2 to the left 1. Down 2 to the left 1. Because this sign right here, we know it's a solid line. So just drag a line. You hold it. It makes a perfect solid line for you. Okay. Now this is where we get a little more interesting. I'm actually going to have us do the possible solution. Because there's only 3 of these, then we're done for the day. Okay. This is where we see which side of this works. So there's 3, or technically 4 zones that could work. We have zone 1, zone 2, 3, and 4. Okay, so let's start with zone 1. We're going to make an easy point for these and see if they work. You're going to have to test it for each one of these. Okay, we're going to test point 0, 0. Make it nice and easy, first one. Okay, so 0 is less than, let me zoom in a little bit, less than negative 2 over 3 times 0 minus 3. Any number times 0 gives us 0 minus 3. Oh, we know right away that negative 3 is not greater than 0, so that does not work. So we know, at least for this first one, this side doesn't work. Okay. Now let's check on number 2. Let's check this side over here. Now I want to use the point negative 1, 1. Okay. So we're going to use y as 1 and x as negative 1. Okay. So a negative times a negative gives us a positive. 1 times that always gives us the number it was. So 2/3 minus 3 is greater than 1. That leaves us with 2 and 1/3, negative 2 and 1/3. We know that's not true, so that doesn't work for that problem either. Okay? So we know it's not going to be zone 1 or 2 right now. Let's try 3 and see if it works. We're going to pick that number right there. It's going to be negative 2, negative 2. Okay? Make it as easy as we can on numbers. Y is negative 2, and x is going to be negative 2. Now, this is where you guys may need to use more calculator to help you out. So if you do negative 2 divided by 3 times it by negative 2 is going to give us 1 and 1/3 minus 3. So you take 1.333 minus 3 is going to give you negative 1.66 or negative 1 and 2/3, which we know is true statement because negative 1 is bigger than negative 2. Okay, like I know the negative numbers get confusing, but negative 1 is a bigger number than negative 2. So we know that works for that one. So let's try it on number 2. Okay, part 2 here. So we said negative 2 is y greater than or equal to 2 times negative 2 plus 1. 2 times negative 2 is negative 4. Plus 1 gives us negative 3 is less than or equal to negative 2, which works. We know that's true because negative 2 is a bigger number than negative 3. So we know that this zone 3 is a possible solution. So we shade this zone just like that. Okay? That's all you have to do. So we know a possible solution is negative 2, negative 2. Now let's try this next one. This is going to be the last one I do because I'm not going to... Let's skip B. I'm going to do letter C because I want to make sure you guys understand how to do this one here. So let's look at this first part here. This first part here is a little trickier. You have that, and that for this one around. So x is greater than or equal to negative 3. There is no y. So we just look at the x part. We see negative 3. We make a dot there. And what that means is this is going to be a solid line because of this symbol here. And it's just going to be a vertical line just like that. That's it for that part there. Now if we look at here, we have things a little different now. We have to do like we did in the last one is get y by itself. So we have to subtract. So I'm going to pull up here. 5x minus 3y is greater than negative 9. Greater than or equal to negative 9. We have to do minus 5x on each side, which leaves us negative 3y is greater than or equal to negative 5x minus 9. Now we divide by negative 3 to each of these, which in turn, the symbol here is going to flip. So now that means that symbol flips and faces the other way because we divided by a negative number. So that leaves us as y is less than or equal to negative, or positive, because it's two negatives, 5 over 3x plus, because it's two negatives, we know 3 goes into 9 3 times, and we took this problem here and turned it into this problem right there. Now we have our y-intercept, our slope, and lastly, what our line's going to look like. So now we know plus 3. So we go up to positive 3. We know our slope is going to be 5 over 3. So we have to count up 5 and then to the right 3. 1, 2, 3, up. Can't go much higher. So now let's test the other way. Let's go down 5 and to the left 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. Can't go much lower. So that's the best we can do, is those 2 points. Because we have this symbol there, we know this is going to be a solid line. Drag and hold your line. It's going to give you the best shaped line to the point that you can. Now once again, we have to find possible solutions. We have 4 zones. We have zone 1, zone 2, 3, and 4. Okay, so let's try with 1 first right away. We're going to go with the easy point of 0, 0. Okay. So for x, we just put 0. 0 is greater than negative 3. Well, we know that one worked. So let's test the second part here. Y is 0 greater than 5 times 3 times 0 plus 3. Number times 0 gives you 0. We know 3 is greater than 0. We know that side works. So right away, we got lucky here. And the first thing we guessed works. Does not always work that way. Sometimes you have to do all 4 before you can find out a problem works. And that's all you would have to do. And then you write in the possible points of 0, 0 right here. Okay. That is where I'm going to stop for today. Tomorrow we'll pick up with the rest of these. If you feel up to it, do B on your own, and I'll check and see how you did. We'll do this tomorrow and finish off the rest of this in the next couple days. If you have any questions, please feel free to reach out to me via email or Canvas, and I will get back to you as fast as I can. Have a great day, guys, and I'll talk to you tomorrow.